let's analyze what all strings that this automaton can accept. So we say a string x is accepted by finite state automaton if starting from the start state, namely q naught, starting from q naught, simulating x on q naught, FSA reaches one of the final states. Okay, if starting from q naught, simulating x on q naught, if FSA reaches one of the final states, we say so and so string is accepted by the finite state automaton. How do you formally describe delta of q naught comma string? It is a string, so let me use delta cap. It reaches some state q which belongs to the set of final state, and if this is the case, then x is accepted by FSA. So what is a language? A language is set of x accepted by FSA, which means language L is all those x, and where do the x come from? X is coming from sigma star, and delta cap of start state comma x takes me to q, and q belongs to f. This is precisely my language. We say set of valid strings or set of strings accepted by an automaton. That's precisely the language. And where is this coming from? It is clearly coming from sigma star. Not all of sigma star is accepted by this, only a subset. The subset that is accepted by the mission, we call it as a language. Okay, and just like natural language, this is our language. This is called formal language, and this formal language tells you strings accepted by this mission. Okay, now for this mission, let's look at L. Now, will this mission accept 1? Yes. Will this mission accept just 0? Delta of q naught comma 0 is q naught, and q naught does not belong to f, which means the string 0 is not accepted, or it is rejected by this mission. And will it accept 1, 1? Yes. On reading 1, you go here. On reading the next one, it comes here. Please note, the description is such that you can only read a symbol. Okay, at any point in time, at a state, you can only read a symbol. Now, I read a 1 followed by a 0, then I read say 2 more zeros, then I read a 1. Look at this string. Now Q0 comma 1, I'll go to Q1, then Q1 comma 0, I'll come to Q0, then Q0 comma 0, Q0, Q0 comma 0, Q0, Q0 comma 1, Q1, which means at the end of this string, which means on simulating x with respect to Q0, so starting from this and after reading this, I should come to one of the final states. If that being the case, the string is valid. Then you may read many zeros followed by a 1, that is accepted by this mission, or you may read couple of zeros, then couple of ones, again couple of zeros followed by 1, that is accepted by this mission. If you carefully observe this, all of them, they have this property. It is a string ending with a 1, correct? Now you have sequence of ones, yes, it is a string ending with 1. You see that all strings that are part of this, they have this property, and they have this pattern that before this it could be anything, but if you look at the last symbol, it is always 1. So this mission is trying to compute this, or this mission is trying to recognize such a language. That is the computational task achieved by this mission. That is the computing part performed by this automaton. And now you ask, is a string ending with 1? That's a computation. And can you recognize, can you design, can you construct a finite state automaton and describing this language, set of all strings ending with 1? That's a computational task. Just like you ask for whether a number is prime or whether a number is perfect square, you do this computation, and here is a computational task that is carried out by this mission. That's precisely the computing power of this mission. So if you observe, you get to see that all strings ending with 1 is accepted by this FSA. Okay. And strings ending with 1 are accepted by this FSA. Now that's the language of this mission. Okay. So now like this, we will start constructing some more missions. How do we formally prove that if you supply any other string, it will be rejected, and if it is a string ending with 1, it will be accepted by this mission? All that we will be discussing formally, but the intuition or through examples you get to observe this pattern, and once you get to see a pattern and slowly convert that intuition or pattern into a claim and formally prove that this is the language accepted by this. So what are we saying? You look at a string x and you write this as x prime followed by 1, and you can write this as something else followed by 0. So any string, it will either end with 1 or it will end with 0. Before that, this is a prefix. Prefix could be anything. So this could be anything belonging to sigma star. Similarly, this could be anything belonging to sigma star. What are we claiming? We claim that this is accept and this is reject. So that's precisely what the mission is doing. Okay, so what is that we are concluding? The mission is accepting this language set of x belonging to sigma star such that sigma is given 0, 1 and x is ending with a 1. Okay, it is all strings ending with 1. And what is not part of this? Strings ending with 0, which will be rejected by this automaton. So either we will be asked to construct a mission given a language, or we may be given a mission and we will be asked to identify the language accepted by this mission. Now this is our computing part or computational task. Okay, computing or computational task. So problem like this, it's a computational problem. Design a finite state mission following this requirement. Now this computational task can be carried out by this mission, and like this is a pattern, all strings ending with 1. Now like this, what all patterns that a finite automaton can accept, recognize, and what patterns it cannot. So things like this we shall explore.